Hello, hello, hello. Seems we had some hiccups for a second there with YouTube again, but it seems to be solved. Seems to have solved itself. I don't know why YouTube struggles so much. Twitch and Kick for some reason does not struggle. I don't know. Probably something on my end. Let's see here. Oh, hello, Gojo. Small-eyed cat. Small face cat. His whole head is big. Ugh. No Hollow Knight today. I was too tired. And I wanted to get some more work done on this one. We're on topic 27, generating text. So we're getting pretty far in like two streams. No problem. Yes. How was your day? Monday. Mine was pretty exhausting. So that's the reason why I'm so tired. But even though I'm tired, it should be no problem to get at least a few hours in. It was good? Nice. Not the best. Yeah, as long as it's still good, then you can't complain too much. You need to be a glass half full kind of person. That does make life more enjoyable. Even though I myself struggle with that a lot. But enough about that. Ooh. Let me just get some more tea. Glass is full, the other half is just air. Oh, I like that. That's clever. You never have to specify the element that the glass contains. The glass is full of air, you can say, even if it's empty. Well, now it's time to see how much of the knowledge actually stuck with me for 2 days. Wait, is it 2 days? I guess so. Yeah, 2 days. What, 44 hours or something like that? 45 hours. So, the last thing we did, what was that? See. There's a lot of questions here. So this one was pretty difficult. Let's see. Oh damn, we need to scroll a lot here. Wait, now with topic 24. Can we search here? Topic 25? No, 26. Here. The forward pass test. I do not have any memories of this part. We did all of this though. And this is pretty self-explanatory, I guess. It's initialization, and we're creating an embedding layer. And we created a forward function. So the forward pass test. Right. So we created some dummy data. And we created a bigram language model. Whatever that was. A very tiny model. And we set the vocab size to 65. And we use that variable here to set up the model. And we use the vocab size to create the embedding layer, which we can do on this model for reasons I don't remember. But that's not very important, I don't think so, at least. And then we create the dummy data, xb. This is the input, I think. So, and this is the target we're looking for. And then we pass along that data here as IDX and targets, which then returns logits and loss here. And then we print logits.shape and loss.item. So if we, let's see, scripts, activate PS1, and we do Python, testing ground, Py. Bongo Cat barely covers your address. You're safe for now. Yeah, from IP, yeah. I'm using a VPN though, so that's not accurate. I wouldn't stream without a VPN, that's too risky. But Bongo Cat can cover the fake IP the fake IP anyways. He's doing his job. He's being useful. We shouldn't diminish his work ethic. Now let's see. What do we have here? Torch size. So logit's shape. It's 65 in depth and 4 in length. Since we have 4 items here in total, so that makes sense. Otherwise it would have been 265. The true secret agent, yeah. There probably exists like a secret agent skin for your Bongo Cat if you pay for it. I wouldn't be surprised. I think I have like almost 700 hours in Bongo Cat now. It's not difficult to rack up those numbers though, since it's always on like in the background, so. Okay. So I think I understand, or I remember at least, most of the knowledge we got from doing all of this. Most of it. So I think it's time to go on to the next topic, and we can revisit this if we need to. So, how confused are you, Gojo, from a scale from 1 to 10? See. 6.89. That is a pretty average confusion. So you're following along a little bit, at least. Ooh, okay, we're upping those numbers a bit here. 7.23. I guess you're nearing like pretty confused then. I see. Now then, I can read this first. Let's get back to generating text to To generate the next letter, we need to look at the predictions for the very last letter currently in the sequence. If you have a tensor logit of shape batch time channels, we want to keep all batches, we only want the last time step, we want to keep all channel scores so we can pick the winner. Can you write a script that creates a random tensor, logit equals torch.rand, then so we're creating a random tensor here with this size. Slice it to get a new tensor representing only the last time step. Print the shape of that new tensor, it should be 265. Okay, introducing slicing with I mean, I get the logic, but I do not get the functions. I get the structure of what you do, but I do not get the things like tensors or the torch things. That's understandable. If you have Python knowledge, then that's how it should be. And you can probably like intuit like some things. Like some things of like the functions without actually knowing everything. I wonder if you're like... I wonder if you can ever get to that stage like where you're so grounded in a programming knowledge, like you speak it so well that even if you like see a function that you don't really know what it does, you can still figure it out fairly easily. I feel like you would at some point. Yeah, some understand a little, yeah. See? You're almost there already. Okay, so I guess we should nuke all of this. Bye. Bye-bye. And begin from the beginning again, because we don't need all of that. We only need to create a random tensor and slice it and then print it. There's a programming language called Brain. Really? Nah, you're making that up. I don't believe you. There's no way they're using only special characters, right? I guess someone might actually have made a language like that simply to fuck with someone. Okay, it was made to literally be the hardest to use. Programming language. Esoteric programming language created in 1993 by Swiss student. Designed to be extremely minimalistic, the language consists of only 8 simple commands, a data pointer and an instruction pointer. Okay. It's an example of a so-called Turing torpid. It can be used to write any program, but it's not practical to do so because it provides so little abstraction that the programs get very long and complicated. I mean, at that point you might as well... Oh, okay, so these are the characters here. It might be better to simply program in like assembly at that point. Okay, so this is literally everything, and the text here is simply flavor text. So it's only these characters here. Interesting. Oh. Okay, so this is more like what you'd see, probably. I was wrong about the slash, but you see how it looks. Yeah. But I mean, at this point, Why not simply program in like straight assembly? I'm not sure this is actually even more like... I'm not sure this is even easier to use. I don't know. Didn't someone make a whole game in a pure assembly? Like, it wasn't like the first like roller coaster tycoons made like in assembly? Or have I hallucinated that? Roller coaster tycoon assembly. Oh, here we have let's see, can we have assembly? So some guy called Sawyer wrote 19 episodes of the code Roller Coaster Tycoon in the 32-bit assembly language, with the remaining 1% written in C. I mean, that's mad respect. Like, create a whole game in assembly by yourself. I'd say that's even more impressive. And if I remember correctly, due to the reason it was coded in like pure assembly, it was so well optimized. Like, it was crazily good optimized. Yeah. Okay. Back to this one. And here I am, trying to understand this shit. Even though I have like a teaching resource here those guys could only dream of. Okay. So... what do we need to do? Do we need to have this? No, I don't think so. Because we don't need to do the softmax or whatever it was called. Here we go again. Yeah. Okay, we do need... no, we probably don't need NN either. We only need torch. So logits equals torch dot random. A structure of 2, 5, 65. So we have 2 rows, 5 columns, and 65 channels, or whatever. Or 2 batches, 5 time. I don't know. I don't like the calling that time. It feels so weird. Then I need to slice it to get a new tensor. I don't know. Can we call it that? Wait. Is slice a... oh, it's a class. Okay. Let's call it slog. 2 weeks until Mario steals your liver? What? Why would Mario steal my liver? What? Why? Where did that come from? That came from like left field. Old meme. Oh. I don't know. Okay. Yeah. I mean, there are so many old memes that people have just forgotten. Like, there's a few guys here and there that remember them, but other than that, like, they were just a fad that lasted for like a few days and then they were over. Like, there's so many memes like that. There should probably be like some sort of like preservatory for like dead memes. There probably is like a website or like a archive for stuff like that someone has made. But then I never thought about it before, but that would be pretty interesting. Like, imagine in like, I don't know, in 40 years or something. People going back and like looking through the archive, finding like Uganda knuckles or something like that. The Great Mimic Museum. Nah, you're fucking with me, aren't you? Okay, no. No, this is something else. It would have been pretty cool if there was such a place though. But I don't know. You should probably preserve all of that digitally, because there's like a lot of memes that you can't like preserve in like physical form. It could exist in 40 years. True. For it to exist, there should be a like meme museum website first. I think that's like the necessary step. First there has to be like a meme museum that gets a lot of traffic, like that shows interest in an actual museum, and then they might build one. I can't see them building a meme museum without it like being some sort of digital like equivalent first. Okay, so how do we do this? We need to somehow get the last time step. And of course there's still 2 rows and 65 channels. But we need to get the like... Oh wow. How do we do that? Is there a function for that? I have no idea. I'm not even sure on how to go about this. Do we need to like grab logits? Is it by... Use slicing with question mark, question mark, question mark. Maybe we can simply put 2 here to get both. Maybe. Get both batches or both rows. And then we need to get the last of the columns, or I think you can also call it sequence instead of time, right? But let's call them columns simply for ease of, for simplicity's sake. So then we need to do something like oh my god, how do we use slicing to get the last element again? Do you know that, Gojo? I do think I remember you giving some advice on that before. Maybe we need to do like 0 and 2. That should be 0 and 1, which should be the 2. So we might have to do this to actually get both of them. And in this case we do 3 and 4? Since it's exclusive, we'd only get number 3, which we don't want. We would want number 5 still. I have no idea. 65. Is that Among Us? 9. What is that? What is that character? And Among Us. But I mean, it has to come from somewhere. Right? The Sinhala letter. Okay, so what is Sinhala? Sinhala? Hala. Indian. Sinhalese. You out there dropping Indian lingo like you know it off on the back of your hand. Old language. Indian bro. Are you an Indian tech bro? Suspicious. Let's assume this will work, and then we print slog. We want to know the shape of it. We don't want to know the gibberish data. 165. Well, that's not correct then. I'm lost. I mean, we did like do the flattening and stuff like that. And I guess you could do flattening, but it doesn't say like here to do a flattening. And that feels like a mistake then. Maybe we should include the answer as well. I don't know how. If I don't know if I'm doing this correctly or not. Probably not. Because we're also hard coding like the slicing, and maybe we shouldn't do that. I don't know. You're very close. You successfully grabbed the correct data, but you kept the container around it, which is why you have an extra one in the middle. Slicing range versus indexing pointing. Slicing 4 5, give me a list containing items from index 4 to 5. Result, a list with the one item. Shape keeps the dimension B1C. Indexing -1, give me the item at the last position. Right. The -1 indexing, I forgot about that one. The raw item itself, the dimension is removed, collapsed, shape BC. Also, you can use colon as a shortcut for everything in this dimension. This makes your code robust. It won't break if you change the batch size to 32 later. Okay, so that makes sense. So if we do colon here, it's gonna get everything, and that keeps it robust. And -1 here means we'll grab the last item, or like the last column of each row. Okay. Now then. Let's try and print it. Yep, 265. So that is working. Nice. I guess we're also gonna pass that along, so it knows we've done that. I'm almost out of tea. I need to buy more tomorrow. I think I'm gonna go for a more floral blend this time, if they have it. The one I'm drinking now is very good. Raspberries and like citrusy, but it's a bit sharp on the citrus. That works perfectly. You successfully sliced the tensor to get the exact shape 265. Now we have everything we need to write the generate function. The topic 28, the generation loop. We are going to add a new method to your class called generate. It will run a loop to create new text, one character at a time. The logic: look at the context, feed current history, IDX into the model, get predictions, receive logits, focus slice to get only the last step logits. Okay, like that. Want to read a joke? Sure. Hit me. Slice to get only the last step. Probabilities, apply f softmax to turn scores into percentages. Sample, use torch.multinominal. Probabilities and number of samples equals 1 to pick the next character based on those percentages. Append, add the new character to the history using torch.cat. Cat? Probably concatenate or whatever that's called. Okay, can you update your Bigram language model class to include this method? Wake up your class again. I guess we could simply copy and paste what we already did. Is it this one? Yep. Oop. Okay. Oh, that spacing's weird. All right. Now what? No. There we are. Okay. So we have a function then or a method inside the Bigram language model class. Magician, I can erase anything. Tom, holding up cup. Do it to my tea. Magician, done. Still holding cup. It didn't work. Poor Om. You should have said also, instead of still holding cup, I didn't work. You need to keep the T's gone after after everything. Okay. Generate. So we're referencing the self, IDX, and max new tokens. IDX is B and T, array of indices in the current context. They weren't his. Oh, I guess that's true. They were his words though. For underscore in range, max new tokens. In range 1. Get predictions. I don't know why I'm copying the comments here. There's no point in doing that. Let's see. Logit loss equals self IDX. What does this even mean? We're trying to get the set the logit loss to the... Oh, we're passing IDX through that. We're passing... Okay, so this is... Since we're referencing the self, we're gonna use the forward function here. And since we're not assigning any targets, we're simply passing the IDX through the embedding table and getting logits. And then we return them. So logits will be full, but loss will be none in this case. Aha! Now I feel smart for getting that. Then we're setting logits to logits. The colon minus 1 colon. So we're getting the... We're replacing logits with... Or should I say, we're deleting every column except the last one on each row. That's the only one we're keeping. Oh, I see. And then... And each column will of course be... Because each column is... Or each row is one sentence. Like it's gonna be... All the columns in the row are gonna be identical except for the last one, because that's the new character that we're gonna add. So by removing everything before that, we're only getting the new character on each row. And then we're gonna probably gonna check which of those rows has the... Oh wait, no, that's not how we're doing it at all. We're doing multiple batches. It's the 65 in that. That's the probabilities, right? Ooh, this is confusing. Big brain moment. And it shrank again. Immediately after. I'm like so close to getting it, I think. Like, so close. I'm almost there. Almost. So setting the probabilities to f.softmax. So we're making sure that all the values is between 0 and add up to 1 by converting all the values into a decimal value somewhere between 0 and 1. That corresponds to its size. Probably, yeah. So we do that for the logits. And we only do it on dim -1. Dim -1. Does that then mean the last dimension? I didn't think of it like that before, but that would make sense. And the last dimension is, of course, the channels dimension, or the depth dimension. The one that's 65 in length, holding all the various characters. Oh yeah, of course, we're gonna do a softmax on those to like step by step order them in like their or like get the probability for them. I guess having 2 batches is simply a bit confusing, since having 2 batches isn't necessary. We could have had 1 batch, I think, and it would have still worked. It just wouldn't have been as fast to train. Wow, are you impressed? I'm not even sure if I'm correct in my assumptions, but I think so. I think so. IDX next. We set that to torch.multinominal. Multinominal. I spelled that incorrectly. Nominal. What? Multinominal. Nomial. Not nominal. Nomial. Probs. So we're pressing the probabilities, and the num samples equals 1. I don't know. Oh yeah, this probably means that we're simply selecting one of them. But what does this function actually do? Returns a tensor where each row contains number samples indices sampled from the multinomial. Yeah, so we're sampling one of them. Okay. So we're getting the next ID. Or the next character. And then we do idx equals torch.cat or concatenate, right? Concatenates, yeah, the given sequence of tensors in tensors to the given dimension. Torch.cat can be seen as the inverse operation for torch.split and torch.chunk. I thought that was simply like a addition of sorts. Like concatenating means like you add to something else. This seems like the explanation is a bit more in-depth for it to be as simple as that. Can ask, I guess. But we're adding IDX. Or we're adding two IDX. And what we're adding is ID next. Ooh. And we're doing it in dim1. So we're doing it in the... in the column. Has to be. We're adding a column. We're adding it to the column. Yeah, for each row. So we're adding the choice from the vocab of 65. Whatever we get from there by ID next, after doing the softmax, we're adding that to the columns. You can even see that here. And then we return IDX. So this is a function we can call again and again. To generate the next character, next most likely character. Okay. Then run it. Create a model M equals bigram language model. Vocab size 65. Start with tiny context. Okay. So what? I'm gonna add IDX here, torch dot, or wait. We don't need this, do we? No. We don't even need this dummy data, do we? No. We only need this IDX equals torch.zeros. Torch.zeros, what is this function? Oh, okay, so it's literally creating only zeros. I guess if we want to start by a 0, and we don't want to use torch.run then doing it like this makes sense, I guess. And then d type torch.long. Is that a 64-bit float? Ooh. Ooh, a new item. Nice. Okay, let's ask what's the definition of, or what's the How does concatenation work? And how and what is a p-type long? Is it 64-bit float or int? Let's see, so after we've done that, we're gonna do print m.generate idx max new tokens 100 generate. So what this is gonna do is gonna call the generate function, and we're gonna pass along the idx, which is 0 in this case, like a torch that's basically, yeah, it's basically simply a 0. That's it. And that 0 is gonna go in here with max new tokens 100. And then we're gonna get in a loop here, a for loop. Oh wait. Yeah, this isn't right. These should be inside there. Luckily I caught that just in time. So what we're gonna do in the for loop, we're gonna pass the 0 through the logit, through the embedding layer, and that's gonna give us a 65 size dimension added to the 0. And those are gonna be 65 numbers, I guess, they're gonna represent random numbers, like between 0 and 65 probably. And there's gonna be some probability calculations here, and we're gonna grab the last one of them, or the most probable one, and we're gonna add it to the idx. And then we're gonna do it all again, but now we have 2 numbers, and then we have 3 numbers, 4 numbers, 5 numbers, 6 numbers. And after we've done that 100 times, we're gonna return the string of 100 numbers. Or 101 numbers, I guess. If it works. I guess not. Oh, we haven't saved yet, of course. That's the reason why. So here we have 100 numbers. All random between 0 and 64 should be. Because we do have multiple zeros? I can't find another 0, but 0 should be included here. Probably. We do have ones. I don't see a 65 though. I do see a 60. I guess it doesn't matter. But this seems to be working. Now let's see here. How does concatenation work? What's the d-type long? Is it 64-bit float or int? These are great technical questions, let's break them down. Torch long, short answer, 64-bit integer. Okay. It is not a float. Oh, is it a double that's a long float? Not a long float, but a big float. why do we use it? In PyTorch, layers like nn.embedding or functions like cross-entropy loss represent lookups or indices. Floats, torch.float32, used for math, weights, probabilities, gradients, decimal points are allowed. Longs, used for pointers, token IDs, arrays, indices, decimal points are forbidden. If you try to tell PyTorch, look up the word index at 5.3, it will crash. You must say look up the word at index 5. That is why we force the data to be long. How does concatenation work? Concatenate is just a fancy word for link together. Imagine you have two trains, you want to connect them to make one long train. Torch.cat is the coupler hook. You just have to tell PyTorch which direction to link them using the dim argument. Let's say you have a sequence 1, 2 and a new token 3. Scenario dim 0, vertical stack, you glue them top to bottom. Okay, so this would add a row in this case. Scenario B, dimension 1, horizontal link. This is what we use in language models. We glue them side by side to extend the timeline. Or the columns, I guess. Alright, so since this is done, let's copy that and paste it. Alright, this code is flawless. You have successfully implemented the entire architecture of a bigram language model in PyTorch. If you ran that, you likely saw a big block of numbers. This is technically correct. The model generated 100 new token IDs, but it's not very fun to read. We need to bring back our decoder from topic 23 to turn those numbers back into English. Topic 29, the grand assembly. Let's put everything together into one final script. This script will define the vocabulary using a tiny bit of text, build a story or string to index encoder, and IDOS or index to string decoder. Define your model class, generate tokens, decode those tokens into actual text and print it. Why? Why are you providing me with the solution so readily? Shouldn't I get to figure it out with help from you? Feels weird that it's suddenly sort of acting like ChatGPT and simply pasting the solution without any, like, I don't know, questions or whatever. You're completely right, I got too excited about showing you the finish line and broke our rule. I apologize. Let's step back. You built the engine bigram language model, but right now it only spits out raw numbers like 0, 45, 42, I can't read, 13. We need to build this translation layer to turn that back into English. The decoder. In topic 23, you built story, string to integer, and IDOS integer to string. Now we need a helper tool that uses IDOS to convert a whole list of integers into a single string. I'm wondering if maybe the context window is getting a bit too long. Can't even see the scroll part, so that's probably a yes. I'm probably gonna have to get it to summarize what we've done after today and start a new chat. But we won't begin from scratch. it should improve the speed and accuracy. Hopefully. Okay, so can you write a script that defines a dummy mapping? Okay, it defines a list of integers. The challenge, write the function or lambda named... What's lambda? Name the code that takes that list of integers and joins them into the string hello. Print the result. Hint, you will need a list comprehension. It does I for I in list and the string method dot join. I have no idea. I mean, we need some sort of string, like text, and then we need to use the enumerate function, I think. I think that was the most efficient way to do it. To create a dictionary. Yeah, we can even see it's a dictionary here. And then we need to create or encode the text. I don't remember how we did the map, the mapping in the beginning. I mean, you could do that manually, but that seems inefficient as hell. You'd want to do that in the runtime. You'd want to have a bunch of text and then do the very, very basic tokenization. If you can even call this tokenization, I don't know. Because it's not the byte pair encoding we did with ChatGPT all those streams back. It's been a few weeks though, so I don't remember how to do that on the top of my head. But we might need some help actually with this. No, I don't think so. Can you give me a hint? This might give us just enough information to get it done, hopefully. No problem at all. This is a very specific piece of Python syntax that is easy to forget. Here's the logic broken down into 2 steps. The lookup list comprehension. You have a list of numbers. You need a list of letters. You can do this by looping through the numbers and looking each one up in your Eidos dictionary. What do you mean in my Eidos dictionary? I don't have that. Are you operating under the assumption that I have all my previous code readily available? Because I delete everything between each topic. I mean, I could just scroll all the way up and look at the answer I provided when I pasted the code in. So I can get it. I'm just curious to see if it understood that. That's a huge help to know. I will make sure every challenge from now on is self-contained, so you don't need to scroll back or remember old variables. Do we want this? This might be better. I don't know. It's a bit of a different approach, I guess. For this specific decoder task, we don't need the big model or the huge vocabulary. We just manually create a tiny dictionary to practice the syntax. Okay, so the challenge is to use the list comprehension and the join syntax from the hint to run those numbers into the string hello and print it. To turn those numbers into the string hello and print it. Okay, and it gave us the syntax and everything here, so we don't even need to remember that. But it's probably a good thing to have each challenge, or whatever you want to say, be self-contained. Let's do it like that. It's fine if each topic builds on the last one, as long as that's clear. Clear and done in a way where I can keep working on the same, working in the same project without having to delete things or to conjure things from several days ago. It's also fine if each topic, or fine if some topics are self-contained, as long as that's also evident. That should hopefully clear it up. Okay, so that makes total sense. For now, let's treat this as a self-contained mini challenge to nail the syntax. Once we pass this, we will start a master script where we paste all the correct pieces together, so you don't have to conjure anything from memory. Okay, I guess that's a good idea. Yeah? Yeah, seems the AI knows its stuff. Alright. So I guess we can delete this. Can we delete everything? We probably can. So items to strings. We create a dummy dictionary where we have 0 to be H, 1 to be E, 2 as 2 as L, and 3 as O. Alright, and then we have tokens. 0, 1, 2, 2, 3. So hello. And we want to print that. Let's see, let's go back to this one here. This should be the best one, I think. So, write a function named decode that takes a list of integers and joins them into the string hello. Guess we define that as decode. Ooh. And we need to print. Print what? I guess we need an empty string to start with. And then we can do .join on that to concatenate any number of strings. Any number of strings. And inside this here, we can do itus I for I in tokens. So we're basically looping through this dictionary with these values here and concatenating those to an empty string. If we were to call them decode here, we'd get hello. Hello, yes. Alright, so that should be the function. That is perfect to use the generator expression itus I for I in tokens inside .join, which is Pythonic and efficient. Now we have all the Lego bricks scattered on the floor. It's time to snap them together into your master script. Topic 30, the master assembly. Nice that this is on an even topic number as well. We're going to create a single file that runs the whole show. Data prep reads text. We're going to create a single file that runs the whole show. Data prep reads text, build story itus, the model, your diagram language model class. Generation runs the model to create text. I will provide the data prep and execution code below. Your mission to take the code below and where it says your code goes here. Fill in the complete class diagram language model. You need to include init forward generate. If you need to look back at your previous answers to remember the syntax, that's totally fine. Okay. I guess we can create a new text file. Let's call this master file, I don't know, a file. Yeah, not the best name. I don't feel that creative at the moment though. Alright. So ooh, what is this? Okay, so here we're supposed to create the diagram model. Or we're supposed to define the class for that. But what is going on here? So one data prep. We will use a tiny dataset for now. Hello AI world. This is a test. We're building a brain. Chars equals sorted list set text. So we're converting the text to a set to remove all duplicate characters. Like we only want one L, for example. We don't want 3 of them. And that will be solved with a set. And then we convert that set back to a list again. And then we sort that list. And that list of sorted characters will be saved in chars or characters. And then we set the vocab size to the length of the characters. Then we have the mappings. So we have string to index or stoy, which becomes a dictionary where ch. Okay, so we have the character and its index here. And we loop through I for I and ch in enumerated chars. And this will return I'm just a bit confused why we have it in this order. I'd for sure thought we'd have it like CHI in enumerated chars, but maybe not. It might be that the dictionary that gets, or quote-unquote dictionary, I don't think it's actually a dictionary. It's an enumerate object, but it's flipped, so we have... Because it says iterable string, and then we have the index. But it seems like that's reversed. Yeah, here we can see that, right? So we have the sequence of 0 here as a string, then okay. That's where I have the index here and then the character. So we're storing the character and its index in the string to index here. Then in eros we have I and character, so index to string. And it's the same thing basically, but the other way around. Wait, do we get... Will the character be... This is gonna be sorted, and also this set here will remove any duplicates. So this will be in alphabetical order and stuff like that. And then we will start from 0 and go up to whatever, how many characters we have here. To the vocab size basically. But this one, will it start on 0 and then we'll have the same? Like, is this... Are these actually like... Because index to string and string to index. The string and index still needs to be the same, like linked on both of these. That has to be the case. Yeah. That has to be the case. It's simply a different setup. And then we do decode lambda. This is a new expression. Do not assign a lambda expression, use define a function. Lambda L. So this is like a tiny function. Why do it like this though? For I in L. Does that mean we can call decode somehow? I see. So it's another way of doing this, but with a lambda L function instead, or expression. We could have returned like this and then we could have like tokens here, and then this would be gone, and then we'd return this, and we'd have ethos here reference this one. But I guess this works as well. It's just a new way of looking at it. I haven't thought about it like that before. I didn't even know you could use lambda like that. Okay, but after that we do print vocab size. So we're getting the vocab size. And then the model here is the part we're gonna make, and then execution. We're creating the model from the class we're gonna create, and then we start with the blank context index 0 idx, like so, and then we're generating 100 IDs. Of course, we're generating IDs, yeah, that we're then gonna turn into text later. So model.generate IDX max new tokens 100. So this becomes a list of 101 tokens then. Or indexes, I guess. IDs. And then decode and print. So we print the decode, so we call decode with the generated ID 0 to list. Of course, we want the first dimension here. We want the first row to a list then. Okay. And then we decode that by joining all of those together. Yeah, and this syntax is a bit confusing. It seems that Ruff is also complaining about it. Is it archaic, or is it simply, I don't know. Ruff complains about the way you did decode. We did the decode function. Oh, need to get that one. Another duplicate. That is a very good catch by Ruff. Ruff and Pepe8 complains because your code crashes inside Lambda. The error message just says Lambda, which makes debugging a nightmare. If you use def, the error message actually tells you the function name. Here's the corrected master script with the code written as a proper function. Okay, so even if this would have worked, it would... It's not good practice, essentially. Ooh, and here we also have a encode function now. I guess we can copy it all and paste it like so. So S L. Why S and L? Oh, S for string. But why L? I guess it doesn't matter. Maybe because we don't want to use I again. I don't know. But that seems to be it. Okay. So now we need to create a class. Paste your class diagram language model. And we have the init with the self, right? Oh, def init self. I don't remember if we need anything else. Yeah, we need vocab size here, don't we? Vocab size. And then we want to do super init. Wasn't super init? No. I've forgotten. Okay, we need to go back. Let's see. Wait. No, it's probably further back. Here. Init self vocab size, super dot init. Of course, super dot init. Underscore init. What else? Just set the self dot token embedding table to a nn dot embedding of vocab size and vocab size. What else? No, that's it for that one. Then we have the forward function. We're referencing the self, idx, and targets. None. The logits equals self dot token embedding table of idx. We're passing that through that layer. And then if targets is none, then we want to return logits and a none, because we don't have any targets to return. Or any loss to return. But, then b, t, and c equals logits.shape. Logits equals logits.view. B times t with c. So we're flattening that down. And then targets equals targets.view b times t. We're likewise flattening that down. Then we're calculating the loss by doing f dot cross entropy on the logits and the targets that we just flattened, and then we want to return the logits and the loss. And then we have the generate function, self-referencing, and we want IDX, I think, and we want something else, num of tokens. I don't remember actually. Something like that. Max new tokens. Probably. Yeah. Max new tokens. Like so. I guess we can scroll down a bit to here. Here we have the generate function. For underscore in range, max new tokens. We're looping through all of them. And we're setting logits.loss to self IDX, or we're calling the forward function with the IDX. Why is it complaining about this one? I honestly have no idea why that's complaining now. Then we're only getting the last column and everything else. Both the rows and the seed channels, or whatever you wanna call that one. The depth. Then we have the probabilities, fsoft max, logits dimension -1 for the last dimension. And IDX next to torch.multinomial. Oops, not multinomial. With probabilities and the num of samples equals to 1. Because we want one sample. And then IDX torch.cat, IDX next with the dimension of 1, because we don't want to add to the rows, we want to add to the columns. And then we want to return IDX. Now the question remains, why is this complaining? Object of type diagram language model is not callable. Oh, of course. It needs to inherit nn.module. Now it's callable. Of course. Can remove that. Could have simply copy and pasted this, but I feel like doing it one more time is probably a good idea. Alright. Now let's see if it runs. Oh, not testing round. Now we just do master file.py. So vocab size 22, generating, and then result here. It's just going to be a random string of numbers. With the first number being a space. Probably. Is that entirely random as well? Or it's 0 maybe, in a 0 might represent a space here. Well, I guess it doesn't matter. The text that comes afterwards is completely random. Why is my scroll wheel always messed up? I need to spin my scroll wheel like crazy, and then now it suddenly works again. I don't know why. Probably some dust on the sensors or something like that, but it happens every day, so I don't know. I mean, isn't that dusty? Even like using pressurized air doesn't clear it out for more than like a couple of hours. Okay, the code is flawless. You have officially built a working generative AI model from scratch. I mean, sure. It's not trained at all, so it's more like a gibberish generator, but sure. If you run it, you likely saw something like result, blah 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 blah. Why is it gibberish? Because the model is currently an untrained brain. Its neural connections weights are set to random numbers, so it's just guessing characters at random. We are now ready for the final phase, teaching it to speak. Topic 31, the Batcher, feeding the beast. Okay. We can't just throw the whole book at the model at once. We need to feed it small, random chunks of text to learn from. In topic 24 you learned how to slice, X input and Y target. Now we need a function that does this repeatedly for random spots in the text. Can you write a function called getBatch? The task. Assume you have a global tensor data containing all the text IDs. We'll make this in a minute. Alright. That's optimistic. Define get batch size. Inside the function generate random starting positions. ix equals torch.randint len data minus block size batch size. Stack the inputs. x equals torch.stack. Stack the targets. What are we doing here? Stacking stuff. Why are we stacking stuff? Return xy. This is slightly complex syntax involving torch.stack. If you want to explain stack or randint first, just ask. Please explain. Do we need to go back to topic 24 maybe and look at the slicing? Maybe. Okay, this function is doing 3 heavyweight jobs in just 3 lines. It is the data loader, the shovel that feeds coal into the engine. Let's break it down using the analogy of a long scroll of text. Imagine data is a scroll of 1000 characters long. We want to study 4 chunks at a time. Batch size equals 4. And each chunk is 8 characters long, okay. Block size equals 4. Oh, so we have, okay, so we have 4 random extractions of those 1000 characters that are 8 characters long. And then we study them, or the AI will learn from 4 of them at the same time if the batch size is equal to 4. Then we have torch.randint, the random pointer point. ix torch.randint len data, so we're having the length of the data, whatever that is. If it's 1000 characters, then it's 1000 minus block size, so that's 992. And then we have something here that happens. Parentheses batch size, comma. We need to pick 4 random spots on the scroll to start reading. While len data minus block size. If the scroll is 1000 characters long, we can't start reading at index 999. We would fall off the edge. We must stop 8 characters before the end. I guess that makes sense. Or I mean... we don't actually have to stop 8 characters before the end. We just can't start later than 8 characters from the end. Right. But I guess this makes it easier somehow. Batch size. This tells PyTorch give me 4 random numbers. Oh, batch size, yeah, of course. And okay, so this is just a weird syntax then. The result is ix, a list of starting points. Oh, okay, so okay, then it makes sense that we can't. We need to stop 8 characters for the end. Yeah, that makes sense if it's the starting point and nothing else. That makes sense. So we get random starting points. And then the list comprehension, the cutter. Data. So a list data I to I plus block size. So we're getting the characters from the start position to all the way to this, from the start position plus block size. So 8 in this case, characters in total. And we're doing that for all of the start positions. Alright. Or for the batch size. This loops through those 4 starting positions ix and cuts out a slice of text for each one. If I is 45, it grabs characters 45 to 53. Result is Python list containing 4 separate tensors. Okay, that's clever, I guess. Then we have torch.stack, the binder. What did we call this one here? Okay, random pointer point. And the cutter. And now the binder. Right now we have x equals torch.stack. Right now we have a list of 4 loose tensors. PyTorch prefers a single solid block. Stack takes that list and glues them together into a new batch dimension. Okay. Before stack, a list of 4 items. After stack, tensor shape for 8. Batch time. That makes sense. Yeah. Here is the code of the function. Wait, here's the code of the function. Task, can you add this function to your script? You can put it right above the background language model class. We don't want to see that yet. I feel like we should have all the information we need here. Wait, is there something about the data? No, it's not some. There's nothing about the data. What I could see in that little glimpse. You can put it right above the background language model class. Let's put it here then. So wait, what should we call this get batch. Get batch and batch size. So generate random starting positions. X equals torch.randint len of data, len of len data minus block size. And batch size. So we need data and block size both. Guess we need to set block size somewhere. I guess we can do that here. Block size equals, I don't know, 8. And we also have data. Let's simply do data to an empty list for now. Because this is gonna be a string of characters, right? I think so. And then we can do x equals torch.stack data data I and I plus block size. So we have that range there for I in ix. No, wait. Oh, it's... Wait. I don't see the issue. Oh, because this is not supposed to be a list, it's supposed to be a tensor. Random. I don't know, can we do like so? Torch.tensor. Is it supposed to be... What can we do so, like that? I don't know. I guess it doesn't matter, we can get the data, the actual data soon. But just so it doesn't complain. And then y, so the target, equals torch.stack. We want to do data. We'll do what? I plus 1 to I plus block size plus 1. So we're shifting everything one step. Try in IX. I guess that makes sense since we want Y to be the same size. Then we also need to remove something from the beginning. Then we return XY. Can we do like this 10 wait tuple torch.tensor torch.tensor. I'm just thinking, how do we clarify what we return? Doesn't seem to be an easy way to do that. Oh, it's tuple lowercase. Tuple torch.tensor torch.tensor. Can we do it like that? No. Torch.tensor maybe. Maybe simply tensor? No. Maybe we were simply clarifying that we're returning a tuple. I don't know. I guess there's no point in worrying about that. Alright, so this should be the get batch function. We have the batch size here that we can pass along. Here we also have the block size defined. And then we have ix torch.rand int. So we have the length of the data set minus block size. And we want how many batch size. We want that many numbers. I'm still not sure. Rand int, how does that pick 4 random spots? It returns a tensor. Is this a one-dimensional tensor then? It has to be, isn't it? Because the data is one-dimensional. And it's only when we stack the data down here that we're actually gaining like batch dimension. Both the target and the... oh, what's it called? The target and the quote-unquote input. Whatever we're training is on here. Alright, let's go down to this one. So we have... that's the same. And that's the same, and that is the same. Okay, wait, we need data first. To test this, we need to convert your text string into tensors of IDs. Okay, so this is the actual This is the actual learning step. It just assumed I would copy and paste this. But we did write this, and I think I've learned pretty much from doing that manually, so that's good. Can you write a script that imports torch, defines data equals torch.tensor, encode text, d-type torch long, use the text and encode function from your master script? Paste the get batch function above. Calls xbyb equals get batch train. What do you mean train? Why get batch split? There are no such reference here to is there? Split. Split. No. I think it's a bit confused. Batch size. I'm just gonna do it like that. I did this without looking at your sheet. Hopefully that will get it to readjust a bit. All this glazing. This is extremely impressive. You wrote the entire model class, the generation logic, then did data batching logic from memory. Well, no. From your question, from your oh my god, I'm so tired. From your task. No. Here, from the explanation. That's not from memory, but anyways. You have one critical error in the data prep section that causes the script to crash. You want to try to get batch. Block size is 8 and data in the code is 1. Yeah, of course, because it's simply a... okay. So everything else seems to be correct at least. And now it also knows we have batch size here so instead of split or whatever that was. Okay. The data tensor shouldn't be randomized. No, it needs to encode the text, the list of IDs representing hello world, hello AI world. Can you replace the single broken line with the correct code? We need to call encode function with the text variable. Okay. The question is, where do we do that? Is it down here somewhere we're gonna do that? I mean, here we have IDX, but... probably before that. So after we create a model, but... we may know, wait, even before we create a model probably. So... what do we actually need? We need to encode the text. Do we create a new variable? Probably like that. Oh wait, we can do it here directly, right? No. Not without like that import from future annotations, whatever you call it. Then we can't call encode here, can we? We can? I thought for sure we need to call that after. Let's see, what does it say here? Okay, it's not defined. But if we do import from... Wait, import annotations from future? So, right? No. Guess we need to actually remove that. And then put that down here. But now we're referencing something we want to know. Oh my god, this feels so wrong. We need to do it here. And we'd also need to convert this to a tensor. So, torch.tensor. Is that it? Oh, we have here, okay, wrap the result torch tensor in B type. Torch.long. Okay. Because we want them whole numbers. Okay. Let's give it everything here. You fix the bug. If you run the script now, it will work perfectly without crashing. It will print generating and then spit out a string of random characters. Let's try that, just to make sure. Seems to be working. Alright, now we must bridge the gap between random gibberish and meaningful text. We need to insert the training loop we learned in topic 20 before the generation step. Topic 32, the final training loop. We're going to use the ADMW optimizer, the smarter cousin of SGD. It is the standard optimizer used for training GPT and other large language model. Okay, the syntax is identical to SGD. Diagnostic question, can you modify the execution section of your script to train the model before it generates? Task, create the optimizer, okay. Note IE-3 is scientific notation for 0.001. So learning rate is 0.0001, okay. The loop, create a loop that runs 10,000 times. Inside the loop, get a batch of data. X and Y, XB and YB get batch 32. So that is batch size of 32. So we're gonna get 32 rows. Run the forward pass, largest loss, model XBYB, reset gradients, optimizer.0 grad, set to non equals true. Backward pass, lost backward, ways optimizer.step. Monitoring every 1000 steps, print the current loss so you can watch it learn. Put this code after you define the model but before the generation part. Okay. Here then. Or maybe no, here. After you define the model but before generation part, and this is the generation part technically. So I guess we can do training loop. Possibly training maybe. So to create the optimizer, we do optimizer equals torch.optim.awm model.parameters. We're getting the parameters of the model, and we're setting the learning rate to IE minus 3 or 0.001, which is very low. But if you're gonna do it run it 10,000 times, then that's fine, I guess. Okay, so for I in range 10,000. So we're looping 10,000 times. XB YB equals model XB YB. Wait, where do we get XB YB from? Oh no, wait, what am I doing? I'm reading on the wrong lines. Get batch 32. That makes sense. So we're getting the randomized inputs and the target for those inputs. Getting 32 of them. And we do that each loop, and then we're setting logit and loss to model XB YB. And then we're doing optimizer dot zero grad set to none equals true. So we're resetting that one. Resetting the gradients. And then we're doing a backward pass. Loss.backward. Backward. I don't actually remember what that means. We're passing along the loss to... We're passing it along to the weights. We're like... This is like giving the correct answer to all the weights, I think. And then we're doing optimizer.step to move towards that by the learning rate. So a very tiny step towards the correct answer. And then how do we do that? We do if x modulo 1000 or not x, if I print loss.item. This should only run on 1000, 2000, 3000, etc., right? I think so. Since we're checking that, okay. Okay, give it a shot. This is the moment your AI starts learning. Okay. So this is gonna do some generations, 10,000 of them, And then we're gonna generate hopefully less gibberish of text, like more something that looks like this. Alright, let's do it. Ooh, okay, we're getting a lot of prints here. I probably messed up the math here, so we're printing a lot of stuff. Ooh, okay. I mean, it's less gibberish, I guess. So, how do we... Seems I messed up the print every 1,000 step logic. We do have a lowering... Wait, do we? Or is the loss as equal as bad? I don't know. We can't see further back in that. You're incredibly close, you just fell into the classic Boolean trap. In Python, number 0 is treated as false and another number is true. If when I is 1000, remainder is 0. Python thinks if false, it skips the print. Oh. Yeah, I printed a lot of times then. So if this equals 0. Okay. Other than that, and I guess this is a bit fancier. So we format the string step I loss item. Okay. Okay, so here we can see like the decrease in the loss. And it's fairly radical, considering it started at 3.5 and now it's down to 0.8. And it's not complete gibberish. We have some words that are repeating themselves. All right. Wait, down to 0.1 or lower? Because your text is so short, a low way of order model will simply memorize it. No, man, this isn't really me. Let's give it a wake-up call, because this is the answer. I was expecting a perfect answer, like a memorization, because if it's trained 10,000 times on it, it should have understood the memo by now. Wait, it's incredibly low. It more or less effectively memorized most of the tiny sentence. Why ill-dilding? You might notice the text feels like it's stuttering with a short-term memory loss. This is the flaw of the diagram model. Remember, this model only looks at one character to predict the next. Right. There's no tokenization at all here. Okay, it has no idea you finish writing the word building. It has memory span of a goldfish. Even a goldfish has larger memory than this. To fix this, we will eventually need self-attention, the transformer architecture, which looks at the whole history. The Shakespeare upgrade. Before we upgrade the brain model, let's upgrade the library data. Training on Hello World is too easy. Let's train it to write like Shakespeare. Let's see, a snippet that downloads the tiny Shakespeare dataset, about 1 megabyte of text. Ooh, this seems sketchy. This is sketchy. Okay, I'm not gonna do that. Isn't there like some sort of tokenization as well, where we effectively build a more robust vocabulary that won't produce gibberish like that, won't be as prone to produce gibberish like this, because this result is pretty anticlimactic. I was expecting it to be able to reproduce the short text we gave it, but it simply can't. I guess I should have seen this coming, since it's only checking the or wait, maybe can it be because we're beginning with a blank context? Is that the reason why it can't? Okay, eat the nail on the head. That anticlimactic feeling is the exact realization researchers had in the early days of NLP. I don't know the acronym for that, or what that acronym stands for, but probably something like neural learning, programming, or something. I don't know. You were asking two separate questions here, and the distinction is crucial. Is there a better tokenization? Yes, absolutely. Is tokenization why this model is stupid? Surprisingly, no. Let me prove to you why your model failed and why better words wouldn't fix it. The real culprit is goldfish memory. Your model is a bigram model. That means it has context length of 1. It only looks at the immediate previous character to guess the next one. It literally cannot see 2 letters back. The stuttering bug. Look at your training text. We are building a brain. When the model writes build, the last letter is L. It asks what comes after L. In your text, L is followed by D in building and I in hello. It flips a coin, picks D, the text is now build. How the last letter is D. It asks where did D come from. In your text, D is followed by I in building. It tries I. Text now build I. What comes after I? It says I often after I. L is often after I. It writes L. Text now build. Okay. Even if we use full words as tokens, a bigram model would still produce nonsense like dog. The dog walked. The dog walked. The dog, because it has no idea it already said walked 5 seconds ago. The solution: we need the transformer architecture. This allows the model to look back at the entire history, block size, not just the last token. Okay, so that's where the confusion came from. I thought it looks at the block size, but no. I guess that makes sense that it did not do that. But yes, tokenization matters. Byte pair encoding. To answer your specific question, yes, real LLMs use smarter tokenization. We use character level tokenization, vocabulary approximately 65 characters. GPT-4 uses byte pair encoding BPE. Vocabulary 100,000 tokens. Character level 8 steps to predict. BPE building 2 steps to predict. BPE groups common chunks of characters together. This makes the model faster and smarter, quote unquote smarter, because it doesn't have to relearn how to spell the or ing every single time. However, implementing BPE right now adds a huge layer of complexity. You need a separate training algorithm just for the tokenizer. It's better to stick to characters until we fix the memory problem. I guess I can see that. It is interesting though that we're going this way, because when we used ChatGPT, then the tokenization was like the full focus. It's like I'm seeing like two different directions on the AI development here. ChatGPT wanted to focus entirely on the byte pair encoding, while here this becomes almost like the last step we're doing, it seems like. Okay, so making your model smart, greedy decoding. I can prove your model did learn the text, but the random sampling multinomial made it look dumb. When multinomial sees 90% chance of D and 10% chance of Z, it will pick Z 10% of the time. This breaks the chain. Let's force it to always pick the number one most likely option, greedy decoding. Go to your generate function and change one line. Replace torch.multinomial with torch.argmax. Okay. Torch.argmax. So we want dim1. So in the depth dimension, this has to be like after we do all the flattening and stuff like that. Yeah, exactly. And keep dim true. Okay. So this will give the most likely all the time. No. Is there something else we need to change? I think there's something very wrong here. And I'm wondering if it's because we're starting with blank context here. If this is someone messing it up, I don't know. Because it seems like either Gemini is hallucinating or... Wait, can we do it again? Wait, we can do... In range, let's do, I don't know, 15. And... this should give us some more. Hello, Anja. How's it going? Trying to train this stupid neural network. And it's Yeah, it's very, very stupid. But it's, according to Gemini, it's doing exactly what it's supposed to do. This result A is exactly the perfect demonstration of why we need a better better architecture, the infinite loop trap. You just discovered the absorbing state. Logic. Your model sees a space. It asks what's the most likely next letter. The data in your text space is often followed by A as a text, a brain, so it picks A. The trap, now the history is A. It asks what comes after A. I'm good, dude. What about you? I'm tired. I'm so tired. But I'm also so absorbed in this that I don't want to stop. I'm addicted. Yeah, that's probably the best word. Even though it sounds weird to say that I'm addicted to creating an LLM, I am addicted to it. Did you have a good Monday? A good start of the week? I'm tired because, well, it was a full day. That's it, basically. Went to the gym, went grocery shopping, and helped my parents. And there's a bunch of other stuff I needed to take care of as well. And what else? Cooked dinner, and I watched 2 episodes of the series I'm following, and yeah, the time has just flown by. I slept poorly as well. Yeah, for sure. Nice. Do you have an interest in LLMs, AI, Python, all of this jazz? Because the model is simply and no final loss isn't perfectly memorized yet, it might wrongly convince that space comes after A. Or simpler, it's got stuck predicting A because the local statistical quirk in the training run. Yeah, sure. I can give you a follow. But off the stream. It's probably gonna be in a pretty short while because I feel like my brain is full. It's jammed packed with information now. And it also seems like the learning or the teaching is degrading in quality a little bit, I'd say. So I will need to wrap this up at some point. Okay. The verdict: a model is that only looks at the last character is doomed to repeat itself. It has no plan, it doesn't know, it just wrote A, it effectively has Alzheimer's. It effectively has no memory at all. To fix this, we need to let the model look at the entire history of the sentence. Building the transformer, phase 4. Okay, this is a perfect place to stop, actually. Might as well. What can we do? Yeah, okay, nice. This is a perfect place to stop. Because we're entering a new phase where we're doing a bunch of different stuff. Not to mention that it's been 2.5 hours. And my brain is fried. Alright. We got some work done though, I'd say. Even though we only got through like 3 or 4 topics. Something like that. Still, I had fun. And I hope you guys did as well. Okay. I'm gonna go and hit the sack now, I think. But thank you so much for watching. If you enjoyed it, you know what to do. And in the meantime, you need to take care. And I'll see you in the next one. Cheers!